go sheep. Welcome back to your classroom. Today I'll be teaching you about static electricity and the safety precautions you need to take while dealing with electricity. Thales of Miletus, a Greek person around 500 BC, found that when amber was rubbed with silk, it became electrically charged and attracted objects. He is the original discoverer of static electricity. Static electricity is the first type of electricity to be discovered because you can make it very easily. You can create it as well at home. When you pull off a shirt that has a lot of synthetic fiber on it, you might hear it crackle, and in a dark room, you might even see some sparks. Or if you rub your winter jacket with another person's winter jacket, you might zap each other. It will hurt a little bit. Usually, it is easier to make static electricity in dry climates. In humidity, it is harder. So, it's easier to make static electricity during winter. Now, I'll give you a few questions. Name one way to make static electricity in your day-to-day life. Is it easier to make static electricity in humid or dry places? The answer is rubbing jackets together or taking off a shirt with synthetic fiber. And it is easier to make static electricity when it is dry. Being electrocuted by the static electricity is a result of the friction making you charged as a result. This happens because the electrons are being transferred from one to the other in consequence of the two surfaces being rubbed against each other. The two types of electrical charge are positive and negative charges. A positive charge is made, for example, on a Perspex ruler when it is rubbed with a wool duster. A negative charge is made on a plastic comb when you comb your hair with it. Now I'll show you what a gold leaf electroscope looks like. Here you can see there is a metal cap, a metal case, a metal rod, and a thin gold leaf, and an insulator on the metal rod. When the cap is negatively charged, the electrons flow in the metal, and the charge is spread out throughout the electroscope, which includes the gold leaf. Charges that are alike repel, so the gold leaf moves away from the rod that is next to it. If the cap is positively charged after that, some of the electrons flowing through the gold leaf are attracted towards the cap, so the overall positive charge near the gold leaf increases. This makes the gold leaf rise further. The purpose of this experiment is to investigate how insulating materials can be charged through friction. You need a variety of plastic rods and dusters and a gold leaf electroscope, but you'll also need access to a high voltage supply. Now, move on to electrical safety. There are many hazards while you use electricity. Watch out for damaged plugs or bare wires. Remember, electric fires and toasters have high voltages, so don't touch them. And don't remove toast from a toaster with a fork. Don't connect too many plugs into one socket, and keep clear of overhead cables. There are two types of electricity: AC, which stands for alternating current, and DC, direct current. DC is when a battery or cell is attached to the circuit. AC is when you use the main supply in your house's or a building's main supply. In the direct currents, the current is always in one direction. That's why it is direct. In alternating currents, as the name implies, the current always changes direction. So when it's going right, then it's going left. Then it's going right, and then it's going left. All countries use AC for their main supply. Most countries use a mains voltage of around 120 volts or 230 volts. By standardizing this voltage, electrical devices can be used in different countries, but not all of them. So, for example, if you had a toaster in, let's say, country A, and that toaster has the voltage use of 120 volts, and in country B, it's 140, then you can't use it. But if there was a country C that was also 120, then you could use it there. Fuses were and still are sometimes used in electrical devices for safety. Their main purpose was to prevent a fire. A fuse has a thin wire with a low melting point so that it'll melt if there's too much current flowing through it. If this does happen, we'll say the fuse is blown. The rating of a fuse isn't how good it is, it's the maximum current that can pass through it without melting. The main problem with fuses are that it has to be replaced every single time it blows. Now, a handy little thing called an MCB, miniature circuit breaker, has fixed that problem. They basically do the same exact thing, but it doesn't need to be replaced every single time. The only thing you need to do is switch on the MCB back on when you fix a problem that has caused the MCB to stop the current. Many countries use 3-pin plugs for their electrical supply. The third wire is called the earth wire, and as the name suggests, it is attached to the earth. The live wire is brown, the neutral wire is blue, and the earth wire is green and yellow. It is needed so that when a fault in a wire develops, the current is diverted into the earth, which this blows the fuse or stops the MCB from working, which disconnects the dangerous live wire, effectively saving you. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.